Hello everyone, Andreas here. Today we have, for my opinion, 3 interesting cases that relate to IEDs malfunction. The first one will be with LO40 by Hartron. Hartron is a Ukrainian manufacturer of the IEDs. LO40 is phase differential protection, or it can be named like phase comparison system. And the second case will be with relay from GE L60. This is also a phase comparison system. And the third one will be with IED 670 from ABB. Now it's the vendor is Hitachi. So let's start. I want to ask if you have any question, please type down, write it in the chat. Before we start, a few words about phase differential protection. The main thing that on the both ends of the line there is a relay that communicate one with each other through the high frequency communication channel, and if during external short circuit there will be no pauses in high frequency signal, and during the case with fault on the line, on the protected object there will be pauses in high frequency signal, and protection will trip. For manipulating this high frequency signal may be used different signals, but usually it's a combination of a positive and negative sequence current. Our first case with Hartron LO40. A few words about Hartron. This Ukrainian manufacturer put a big role in Soviet space program and made ballistic rockets, but this time it produces a lot of industrial devices and also relay protection devices. So the case that we have was at 330 kilovolt grid. During external short circuit, we received trip from only from one side. This one. This relay from the substation B side doesn't even started. So the problem was with this relay, and when we started to analyze this case, we don't have from this side recordings, only from that side, but also we have from this substation, and during clearing of the short circuit, this circuit breaker was also tripped. So let's see what we have on the substation A side. Here we have voltages on the top. The line has its own line voltage transformer. We can see that it was phase A to ground short circuit, and the values of the current are very low. This is very powerful source. and also we can see that current disappears, but voltage are present in the record. Also, if we look close, we can see that here we already cleared the fault, so that the time that this circuit breaker was opened. But on the bottom we have this type of signal with pauses, and so we received a trip. This is a phase differential protection trip. Also, there was command sent to this teleprotection scheme signals was sent to substation B side, but it's not tripped. So the problem was with relay on the substation B side, and we removed IED from service and tested and found that protection C react on the currents and voltages in a very strange way. It sees these values around 5 to 10 times lower than it should be. So protection was sent to the factory, and they changed main board. And now we received this ID back, and now it's in work. So what interesting. So to summarize about this case, during external short circuit, we have only one side trip. The problem was with substation B relay, because it saw the primary values much more than it should be, and the relay not even started. So from this side, substation A side, we received this signal with pauses and protection from that end tripped. Let's look on another case with GL60. L60 work in a similar way. This is a picture from L60 manual, but it uses different combination of the positive and negative sequence currents. But the principle is the same. During external short circuit, we receive continuous high frequency signal, and during fault on the protected object, we have pauses. What was the problem in that case is that on 330 kilovolt line, that end is just tripped. There were no short circuit, and let's see. Here we have currents. There's voltages. We can also see that in that case there is also a voltage transformer on the line, so we also can see that voltages not disappeared, but currents are zero. So this 17 channel is this this combined channel, and I can say that this value 137 amperes is not enough to trip, so it's set much bigger, and after that case the protection was tested, and the problem was the IED sees currents and voltages few times more than it should be, and the IED was sent to the factory. At the factory they said that the problem with the main board. This protection is not very new. I believe it was commissioned in 2010 or 2011, and so it's a little bit more than 10 years. And on the factory they said that they don't produce any more such boards, main boards, and they can produce it, but the cost will be as new relay. So we decided to buy a new one, and this is one problem that I'll summarize in the end of this stream. To summarize case, just in one moment, relay from substation A side just tripped without any faults, without any disturbances in grid. So let's look at the third case. It's the most interesting for me. What happened? On substation A and substation B sides we have RED 670s, but communication channel was out of service. It was damaged, restored, but not checked, and on record from substation A side we will see that the currents from the opposite side are present in the record, but as I already said, differential protection was not in service. Also, I want to add that on that side there is no voltage transformers on the line. The voltage transformer is only on the bus. So let's sorry. What we can see here, this is the short circuit. Sorry, I believe that is not just a moment, I'll check. Okay, I found. I open Sorry, I opened from the substation B side record, but I want to start from the substation A side. Okay, so we have also phase A to ground short circuit. At this point, this circuit breaker was opened. Here the fault was cleared by the substation A side. But at this point we lost the voltages on this bus. So let's see in digital channels what we can see. So this is bus bar protection strip, but earlier this is the signal from the this relay. In this relay implemented breaker failure protection, and here we can see a retrip signal, and there a little bit lower this signal is the trip bus signal. So at this moment relay from the substation A side generated signal to trip the bus from the bus breaker failure protection. I want to add that we don't use contact from the breaker to monitor or to start breaker failure protection, only currents. So it just can happen this case. So let's look closer to the other channels. This is one moment. So this is the opposite. Maybe I lie, but the most interesting part is here. So you know, ABB devices allows to write different signals from each blocks, and here the commissioning engineer add to records different signals. So he added zero sequence current RMS value, positive sequence current RMS value, negative sequence current RMS value, and also voltage, different voltages of different sequences. And if we put a cursor on the start of the zero and negative sequence, we will see that it starts like more than 300 milliseconds before the current appears. Sorry. And this is very fun because it looks like relay see the future in that case. But we know that time machine is not possible, so I believe that there was some software problem with relay, and that was led to such thing that after fault was cleared, the IED generated trip bus signal, and we lost a lot of load during that case. So relay was put out of the service, and tested, and this is like test signals that was played in relay before the IED reboot. So sorry, so I opened not after reboots. Sorry. So this time the file is before reboot, and we also can see this strange picture when some channels are in the future and some channels are in the past, and we also can see that in that case relay generated trip bus signal with breaker failure protection, and then it was rebooted and tested again, and the picture was like correct. So start. At this point it doesn't look in the future, so just one trip signal, correct, retrip from breaker failure protection, and only retrip. Usually we retrip without any delay, and trip bus has delay. It depends on voltage level and substation. It may be vary from 200 milliseconds to 400 milliseconds. In that case, relay has 200 milliseconds delay, and this 200 may be found only here. So when the trip command was reset, and after 200 milliseconds we received trip. So we contacted the factory. They said that they need to check this case, but at this point we don't receive any answer, and protection this device is not in work to this moment. So what is common in all the cases that in all three cases protection behaved not correct, and from all advertisings we all know that protection have all monitorings, that protection check all its algorithms, but in this case, in these cases, it not helped at all. So that is one point. What more is that these protections was not very old. So L040 from Hartron and L60 from GE was a little bit more than 10 years, and IED 670 is like new 5 or I can't say, but it was put in work before the war in Ukraine. And what I would want to say that there is a problems with relays that have age a little bit more than 10 years. So the manufacturers don't want to not protect, but produce such types of relays anymore, and we also have some problems with other devices that have like not so big for protection age, like 10 or 12 or 15 years. So why I'm saying that, because I know in my region there is electromechanical protection system that can be 40 years, and they working, and it also might be a problem that, but with electromechanical protection you can repair any part by your hand. I know in my company, and I see a lot of posts in LinkedIn, for instance, where some gold-handed guys repairs power, usually power supplies from IEDs, but it can lead to a serious problem when the relay that have 10 or a little bit more years old, if a manufacturer don't produce such type of relays anymore. And they are expensive. So the final words that I want to say, that I don't think that modern digital relays are good investment, and that because they are expensive, and we have some problems when we need to repair them. I deeply love to work with digital relays, to analyze them, but I believe that industry started digitalization, not finished it. So if we look at computer market, there are a lot of cheap solutions, but we can't implement them in like power industry, because we only have this very expensive, I would say not so reliable, like they say in advertisements. So let me check. If I have some question. I don't see any. So I want to announce the next stream. The next stream will be about the most epic fail that I ever seen. This fail was at 110 kilovolt grid, and subscribe to channel and you'll see it. So at this point, thank you very much for watching this video. See you next time.